vary the flow through the chiller, okay? So there's a lot, because of that, there's a lot of DP points of reference that you can get on this chiller, more so than a normal valve. So for example, you can come down here and you can look at the pressure gauges and you can see pressure differential here, okay? Obviously these aren't the most accurate to look at because they're individually sent, so if one is off, you're not comparing two pressures, you know, there to there directly, you're comparing them individually. So if one is off. So on top of that, to be more safe for the chiller, they're using transducers, pressure transducers right here. Okay. They're measuring the pressure differential.
So are these variably driven? Because I see two-stage on here. Is it two-stage or variable?
Which one? The chiller is variable speed. Okay. We'll get to that. I just wanted to talk about how the flow goes through it. Yep. So the chiller is obviously the cooler side is here because it's insulated, so it's lower than the condenser. They're going to vary the flow through the chiller until it reaches a minimum set point value that the BMS system has in here. And then when that is hit, to not go below it, because that could be bad for a chiller, there's a bypass valve down at the end of the loop over there, and that valve starts to open to maintain the minimum flow rate. Okay, so the chiller can vary the flow between, say, I don't have it with me, but it's in the submittal of the data if you want to know what it is. The flow between a low and a high. Okay. And so this is the cooler. Our main power panel here, which distributes all the low voltage power. This is 115 volt power to the oil heater and oil pump. And here's your oil filter right here. Here's your access to the oil pump is actually built right into the compressor. If you put your hand on here, you'll feel it's really hot. Yep. Because when the chiller turns off, the oil heater turns on. I don't know if you can actually hear it. Periodically, when the chiller's off, the oil pump turns on. Agitate the oil and make sure it mixes and gets the heat distributed. So that's in the oil basin below. The sight glasses, obviously you can't see them now where they're supposed to be, but you would see this sight glass would be about half filled with refrigerant. It's a refrigerant cooled motor, so the liquid, you're getting liquid from the condenser here, comes through an expansion device back here, provides the cooling liquid that cools the motor. Okay? This is a two-stage compressor, not like a typical compressor you see, one stage. It's actually two stages of compression, two wheels. On the first wheels, your inlet guide vanes, which is your actuator right here. There's actually suction coming up through the inlet guide vanes, controlling the gas flow to the compressor. Okay. So one thing about VFDs I try to get across to everybody, because there's a misunderstanding in the industry, that the capacity of the machine, the machine controls capacity of the machine based on the speed of the VFD. That's not really how they work. Okay. The reason why you have inlet guide vanes is because the inlet guide vanes controls the capacity of the machine to maintain your set point, whatever that be, 42. Okay. The purpose of the VFD is to, whenever the lift, the pressure differential between the condenser and the cooler starts to drop. You gotta get that break. Commercial breaks. Commercial breaks.
Yeah. Who's here? Just so.
One person from the Cushman Wakefield.
Cushman Wakefield?
Yep.
Okay.
So there's no other operators. He's going to have to remember every single thing I say.
Okay. And these guys are all Turner? They're Turner?
Turner people.
Yes.
Yep.
Turner.
We've already had the discussion with him about the fact that they don't have any solid separators and or chemical feed systems on the tower. So at the end of this turnover period, when this is going to be turned over,
right,
these should be opened. And I told him to talk to you and him about getting your cards so they have
right,
a contact person.
Okay.
But they should be open to clean.
Yeah.
Because they'll probably be. Here's where you can tell your approaches, your pressures, your temperatures here, and your temperatures here. Condenser is here and here. So the approach was pretty close. I wish it was running. I could show you it. Yep. If it starts, keep your eye on it. The data, I print out a bunch of these maintenance logs. So if you want to use ours, if you have something on your computer you're loading up, that's fine. If you want to use your BMS, fine too as well. But as we recommend, there's nothing better than walking around a machine. Absolutely. Put your hands on it. You can't see the oil or the refrigerant level, oil level from a computer. The heater's working and things like that. And you can hear things too if the compressor starts running. You've done this. You've done this. The interface is pretty easy to use. It's like probably most of you've seen. Here's the home button to get you back to here. If you wanted to see what's going on with any individual component, you could just push on that component, and that'll give you all the stuff, how fast the VFD is running. I didn't finish the discussion when you started. Okay. So what happens is the inlet guide vanes are modular and they can be controlled to the 42 degrees. They're regulating the amount of gas going into the first stage of power. Okay. The VFD senses when there's less pressure differential between the cooler and the condenser. I think we'll start up some process. Either that or heater just turned on. It will turn. Okay. The heater will turn on and off as needed. So the pressure differential in here is what allows the VFD to slow the speed down. Not as much the capacity. So if you had really cold power water temperature today, that VFD would slow all the way down to its minimum, which by the way, minimum on a centrifugal is about 65%. You go below minimum, you get stall or surge. So the wheel's not turning fast enough to spin the gas up to high enough speed to create compression. So that's why you have a minimum speed.
From an efficiency standpoint,
Yep.
is it better to run your cooling tower water a little bit lower?
Absolutely, yeah. Because this machine will run more efficient because the speed of the compressor will slow down.
Right.
Yep. You will consume more brake horsepower of your tower fans, but they're smaller fans.
Right.
This is a bigger motor. This is the biggest energy sucking device in the building. So we try to focus on him first, everybody else secondary.
What's your recommendation, like 78?
Minimum tower temperature about 75. If you got a good load, I use 75 as an all-encompassing because a low load wants, believe it or not, higher temperature to move that refrigerant through the system. But if you're at high load, this machine could run fine with down to 55 degree water. So rather than give you all different numbers, if you stay at 75, that use it all loads.
Okay.
They're actually supposed to be doing a head pressure control logic on this job, which they're not set up doing correctly yet. It's supposed to look at the output of the chiller. We have an output that tells the BMS system what speed to run for how much water to flow through the chiller.
Okay.
To create the pressure differential we need. So that output is supposed to be used. They didn't set it up that way for some reason, so they're working on it. The machine does have differential pressure sensors. Now we're on to our third. We got the gauges, we got the transducer, and if somebody could open that up, anybody got a screwdriver? Anybody here? Anybody? Sorry, I have a key and I could do it if I was tall. Anybody tall?
He's a timeout.
Bingo. There you go. That's you and me. Thank you, sir. So this is the control panel. All the microprocessors are in here. We're using the IFM electronic flow sensors. So these flow sensors aren't looking to control anything. They're not modulating valves or anything. These just prove that water's moving.
Okay.
And barely moving. This is 0.5 feet per second tells this to make, and then the chiller can start. Reading buttholes. The way these work is they're called calorimetric sensors. There's an electronic probe in there, and the speed at which the fluid flows past it dissipates the heat off of the electronic sensor. So the rate of heat dissipation tells it what the velocity is across the flow. Pretty cool stuff.
Yeah.
Very reliable sensors. The IOM manuals are in here. They have that. I printed these out from the manual, so they have that. If you ever had to turn off the machine, preferably turn it off from the BMS. That would be number one. The second thing would be, option two would be turn it off from here. Okay. The worst would be turning it off from the emergency, any kind of emergency, a disconnect, or because there's no sequence. When you hit that button, boom, it's off.
Right.
You still have a ton of refrigerant in your cooler, right? What's going to happen? It's still going to boil, and it's still going to cool the water on the other side of it. So you could actually, it's been known people could freeze a chiller, basically. So to unlock it here, to get into the, if you want to acknowledge an alarm, you have to log in first. You can only log in as a user, user. Your password is, can I say this on the video?
Yeah.
Okay, it's 1111. Now let's take some time to remember that, guys. Anybody want to?
I think that's the code for almost everything in here.
Exactly, 1111. Hit enter. Our lovely panel is not that intuitive when you're, if you put 1111 and you hit done, you are logged in, even though it says check here, login level user, but it still gives you the enter. So just realize you are logged in.
Okay.
Okay. You can set up different passwords for different people if you want to know who is the logger in. variable flow we talked about. The pumps are going to vary the speed of the flow through the chillers. The chiller will react to that. It will unload and load to maintain set point. We're up on springs, just to let you know, because we're above occupied space, I assume. Go over to condenser water side. So when we clean condensers, the condenser side's over here. Pretty much it is clean here. You're going to have to get some overhead pull change or a gantry, you know. Pull these off, and then you'll take a toothbrush. You can drain it from here. Toothbrush, brush them all out. Clean really good. Let's go around to back some of the other chillers. This is great. One day we're doing there's nothing on the chiller, VFD. This is the, so we have a two-stage compressor. So because of that, we have an interstage economizer. This is where the interstage economizer float is. There's actually a refrigerant float in there. We walk around to this. You can actually see the refrigerant boiling in those windows if you look in there. Filter dryer for the coolant for the for this guy here. This is refrigerant cooled. It's not water cooled or air cooled. So there's a heat exchanger. Sorry, I'm not seeing where it is, but you probably have to get up on the ladder to see it. There's a heat exchanger that keeps this cooled. You should never have to go in here. I'm not even sure why it's open right now. Oh, because they're making power connections still. You gotta get power to it. Your expansion device is right there. This is a fixed orifice expansion device. So the liquid comes down from the condenser, goes right through the expansion device and up into the cooler. Okay. Isolation valves. If we ever had, or your service engineer, or whoever does your service, ever had to get in the machine, he can isolate the charge. Close that valve, isolate it in the condenser, and then you can open up the compressor and open up the machine without pulling the charge out.
Oh, nice.
You can also pull the entire charge out too as well. You need bottles to put it in. What else? You're basically, your control panel is what you're going to be working on mostly.
Right.
You know, you're acknowledging alarms. On the screen, hopefully we can get it started, because on the screen it tells you what status it's in. It'll say if it's in, there's a lot of alerts and alarms. Alerts don't trip it. Alerts say, I'm feeling a little sick, but I don't want to take work off just yet. Okay, but at least you know something's coming. So,
Chiller valves, they're automated, connected to the BAS.
these are not connected to our system, they're connected to the BMS system.
Right.
Yep. So they're opening up the valve.
So as a chiller is online, the ones that are offline should go closed.
Yes, correct. And I'm not sure they're going to do it this way, but they should do it this way. When they go from stage, if they have one machine running and they're ready to start a second machine, the best way to do that is to demand limit or unload the first machine to 50% first.
Okay.
Open up the other valve and then start the second machine. Once that machine's gotten up to 50%, it'll load up. Then release the force on the first machine. And the reason why you do that is because these big ass valves right here, can you say that on the video?
Yep.
Those valves, when they open, they're not
PG
linear.
rating on it.
Those valves are not linear. If they open up a little bit, it's a huge gush of water.
Right.
So if that valve opens while that machine's running, what's going to happen to the flow through the running machine? It's going to disappear.
Yep.
The machine's going to go, holy cow, I got to catch up. It's going to try to catch up as fast as it can, but it's got inlet guide vanes to control, it's got a VFB to control, it's got the float, it's got refrigerant level. It can't react quick enough, so it's going to trip. So to prevent that from occurring is you demand limit it first, and then you turn on the other machine, then you release the demand. And same for the third, and vice versa when you go through the whole thing. Just so you know, maybe you want, these are getting powered up. They had a power issue, but they found a resolution. So that's why they're going to get these powered from a different plan. But it should work. The engineer was okay with that breaker size.
Yes.
I think it was okay for permanent.
So it was but
800.
design wise, they wanted a 200 amp breaker to feed the chillers, but based on the submittal, it's 800 amps should be enough.
Yeah, I know. That's why I said it.
It's like I think the FLA was around like
Well,
6.
we list on our submittal maximum maximum
Yep.
overload current protection.
Yes.
But that's not the actual load of the device that's supposed to protect them. It's just the maximum you can go to.
Right.
UL requires that. It's a code thing. You have to label it. So if you do the math on the actual full load amps, an 800 amp breaker works just fine.
Yeah.
Right.
We had
And
enough
You're never going to
flash.
start them all up 3 at the same time.
Correct.
Yeah.
No.
Yeah, there was an issue with
Plus they ramp
one of
low.
our
They
subs.
soft load.
In here, don't look at me.
So there's your discharge elbow right there. Compressor gas coming off of there. You know, gas, I don't know, is there good cutaway in that picture I gave you? It shows the compressor a little bit. Kind of sort of right here. Yeah. Gas comes in, goes through the first stage, around to the second stage, and then it goes out. And what they're doing is they're siphoning some of the cool refrigerant that's boiled off from your liquid that came out of your condenser, and they're taking that back into the second stage, and that increases your subcooling effect because it cools the refrigerant going into the condenser. Okay. So that's called interstage economizer. It makes them more efficient. That's going to cost some extra. I don't know. The log reports, you can have. I printed 4 copies. You can have them. This is the panel. Just quick sheets. I print out the pages to show how to use that panel. This is a quick cheat sheet. So, but again, looking at the screen, it's not. Let's go take a look at it.
Careful. Good catch that.
Your relief valves should be checked periodically. When I say periodically, 3-4 years maybe or so like that, because those things, you know, and if they ever do relieve, industry's practice is to have them replaced. Even though they're back seating and they will prevent the charge from being lost, they're saying once they release the first time, it's a good idea, right? But replace them. So they're right there. I guess what you could do to test them is with a refrigerant sensor. You probably have a service company do it. But if they pick up a point, go up there and put a refrigerant probe in there, they could sense if there's a leak on those relief valves. So there's dual on a tree.
There is a refrigerant monitor?
There is somewhere in here.
Because typically they now blow.
Should be.
Yep. Actually, I
Gas station
decided
right
it, but
there.
we haven't. When do you require startup? Because the guy keeps on asking me.
For
Did they run the tube? They have to
starter
run
tube?
the tubes for the refrigerant monitor.
Exactly. He should be running those.
Sir?
So hopefully this week.
Okay. And he can put them low somewhere around here, low to the ground.
Low to the ground.
One below each machine.
Okay.
You know, that should be good.
And I know I don't know if this was resolved, but the number of slots for the two
Yeah,
days?
there's only 4,
Right.
so you only can run 4. So put 1 in each machine, and then you don't have to use the 4th, but if you wanted to, you could.
Right.
I would just suggest putting it.
Refrigerant drop.
Yeah, low point.
You're still going to test a sequence on that. I assume that's tied to a big fan somewhere. That
Yeah, there is fans to exhaust out
Yep.
the
The
space. I'm not
exhaust.
sure
Yep.
where they are.
The exhaust is the exhaust fan is in the roof.
Okay.
Right.
Where's the
For
duct?
that's the one that we looked at yesterday. Yes.
Yeah. Where's the duct?
The duct right there.
Back over there.
There's one right here. There's one right around there. There's duct work.
One for each chiller.
Correct.
Gotcha. Good. Perfect.
There's like 4 of them actually on the
Yeah.
entire.
Yeah, I'm not sure where the fourth could be. You could put it anywhere. Some people put them actually in drains because if refrigerant does leak, it's going to go to the lowest point in this room. And if there's a floor drain anywhere around here, maybe put it right at the drain or actually down in the drain if it's a dry drain. You know, I don't know if you're going to be using it. It's just a rubber tip. I don't think that the type we're using is the rubber. Yeah. I think that's your set point, but they're resetting it up right now because they don't want the pipes to sweat in the building. Right. So they're running the chiller at 50.
Even at 52, we were still planning on 155.
Yeah. Until this building's sealed up, you're gonna.
Exactly.
So you don't want your building sweating. Not that we can see anything, but you can just look at the screens and what they look like. Yep. Like an alert, you wouldn't have to go into reset, so there's no reason to go in there and look at it.
Just be careful too on clearing alarms, because if you have to call
for warranty or anything, it's better if the guys have a history of what alarms, because that happens a lot.
Yeah.
Guys will come in and start playing with the panel and start clearing the alarms, and then our tech will show up and
Yeah.
they'll be like, well, what was it doing? Well, I'm not sure. It was something about flow. You know what I mean? But if you see something about flow, it's always best to check and make sure you've got your flow coming in, your valves are all open where they're supposed to before.
But look at one of the alerts. The alert store. So you have about 20. I think there's 25. But look at high condenser approach. Yeah.
Or even if you have so many, take a picture of them. If there's going to be some, just because it's easier for the techs when they come out to know what's going on.
Yep.
Yeah.
Absolutely.
High condenser approach. So we're doing some kind of head pressure control logic right now, which isn't being done right. It needs to be corrected. We've let them know, but they just haven't gotten around to it. Like I said, there is an output signal that they should follow for controlling the tower water temperature. I'm going to take a picture of this just so I have a record of it. This is like a good thing to do if you want to get a hold of us. Send us, just email us.
Who was the installing the contract?
Classic.
Alaska did? Okay.
Okay, class, any questions? Class?
No.
No.
I'm good.
Yeah. You all set?